Today's video, I'm going to try and explain what the situation is with all of the new things that are going on in ExpressLRS with regards to the transmitters, the receivers, and specifically the RF chipsets, because we are in a transition period with ExpressLRS. We had the original system that worked with everything that was based on what was generally either the SX1280, the 1281 chipset, or the version for the lower bands. We then, though, have recently seen the release of new radios and receivers that support a new LR1121 chipset that offers not only dual band capability, but some great features like Gemini X. As a result of this, though, there are some differences in what is compatible, and there are some things that people simply don't grasp with regards to what they can do, what they can't do, and really the why this is the case. So what I wanted to do is to put a video together to try and explain the situation as of today, so you have an understanding of what you are going to buy moving forward, what you should buy, and what you need to take into account before you do make your purchase. Now, just before I get into this one, I just want to say I will be showing hardware in this from the likes of Radiomaster and others, but this video hasn't been sponsored. No one asked me to make this video, although if you do want to buy any of the hardware from Radiomaster, there will be links, but you can go and buy whatever hardware you want. What's important here is that you understand the technical differences when it comes to the chipsets. Now, ExpressLRS is an open source flight control system that is designed to work on many different pieces of hardware. There are two specific types of hardware, though, that was chosen for the main system. We have our low band compatible hardware and we have our 2.4 gigs or high band compatible hardware. Now, when it comes to our hardware, there are a couple of things you need to understand. There is our microcontroller that runs the ExpressLRS software. That is generally either an ESP32 in a radio, or it might be an ESP8285 in a receiver. And then you've got the RF chipset that does the actual communication between your radio and your receiver, and that is what is different between the high band and the low band hardware. So for instance, what you see here is 2.4 gigs. We have a Ranger Nano module. We have the Beta FPV Dual module that supports Gemini, and we have a Radiomaster Boxer. All of these will have either the SX1280 chipset or the SX1281, and that is the chipset that works on the 2.4 gigs band, and that is the chipset you'll find in these receivers as well. When it comes to the low band hardware, again, the microcontroller will be the same, ESP32 or an ESP8285. But when it comes to the chipset for the RF communication, because that is running on a lower band, that instead of being the SX1280 will be an SX1276, and that is what you will find in the likes of the Bandit series of modules from Radiomaster, as well as many of the other low band compatible modules. The thing to understand is, on the original hardware, the main microcontroller would be the same, but the different RF chipset would dictate if it worked on high band 2.4 gigs or low band 868-900. Now, what was common across both of those two different RF chipsets was the fact that they both supported LoRa modes, with our SX1280 series also supporting FLRC modulation, giving us that very low latency F modes, and our SX1276 series technically supporting FLRC, but them only implementing LoRa. This allowed the ExpressLRS team to build up the big list of different modes that we would see available in ExpressLRS. You had your LoRa modes, which are the chirping modes, which are great for long range. And then you had your fast modes, your F500, your F1000 modes that were great for very low latency. These modes were compatible across the board, and whilst there were differences in the rates available between the high and low bands due to limitations, the fact was both of these chipsets supported LoRa and both of them supported FLRC. Now, a little while ago, we saw the introduction of a new RF chipset called the LR1121. Now, the first module we saw this in was this, the Radiomaster Nomad, and we've recently seen the release of the GX12 from Radiomaster that also had this module built in as well. Now, this new chipset offers a number of big differences, and the biggest being that it is dual band. So rather than on the old system have one chipset for 868-900 and one chipset for 2.4 gigs, the new chipset allows it to do either. This chipset supports both 868-900 and 2.4 gigs. So rather than having to make two separate products, two separate modules, now your single module is capable of dual band. This has allowed not only the introduction of dual band radios, but it has allowed for the introduction of new modes, including the new Gemini X mode that allows the system to transmit on both 868-900 and 2.4 gigs at the same time, giving you some of the best options when it comes to radio redundancy. Whilst you could have dual transmission on the likes of the original chipsets, just like this Beta FPV module here, this would only allow you to dual transmit on 2.4 gigs, whereas the new LR1121 chipset allows you to transmit on both bands. Now, something that's just worth me highlighting at this point with the releases that we've had with the new LR1121 chipset is that both the Nomad module and the GX12 from Radiomaster are dual transmitting modules. They actually have two LR1121 chipset modules installed, a bit like this Gemini X module from Beta FPV. This, though, isn't a requirement of the new chipset. There is no reason why you won't see transmitters in the future with a single LR1121 module installed. The only limitation of that will be that the single LR1121 module based receiver and transmitter will only be able to work on either 868-900 or 2.4 instead of being able to do it on both in that Gemini X mode that you see here. These initial radios and modules are designed to be the premium end of what the LR1121 is capable of doing, but we will see more standard radios and receivers come in time. Now, as a result of this new chipset, there are some changes needed on receivers. For instance, this here is a dual chipset Gemini X receiver with independent antennas. Here on the back, we've got the ESP32. Over on this side here, we've got dual LR1121s, and then we have individual antennas for each band. So there is a single 2.4 gigs antenna for that chipset and a single 868-9 antenna for that chipset, and then you've got the same for the second chipset. This is a more complex receiver compared to some of the others. You've got this, the new XR4, which has just released from Radiomaster. This one's in heat shrink tubing. Again, ESP32. This again has two LR1121s, so this is full Gemini X capable, but this receiver has only two antenna ports, so each antenna port can do either 868-900 or 2.4 gigs, and this one is set up with dual band antennas. For your more standard traditional receiver, you've got something like this, your XR1. This again is in heat shrink tubing. This is a single chipset receiver, so you've got your ESP32 and then you've got your LR1121. We've then got our filter in here which works on both bands, and then we've got our antenna. Now at the moment I've got this receiver connected to a 2.4 gigs fixed antenna because I'm only using this in a 2.4 gigs mode. However, if I wanted to use this on 868-900, I could swap the antenna out for 868-900 and select it in the software, or alternatively I could also use it with one of these dual band antennas as well. The real big benefit here to this is the fact that you're no longer limited to the band via the hardware on this one. You can choose the band you want and select the best antenna, or alternatively use a dual band antenna. Now, even though there are receivers like this. There are still now smaller receivers with those little antennas like we saw in the past. You have the little tower antenna on this. Whilst this is based on the LR1121, this receiver is limited to 2.4 gigahertz because it has the 2.4 gigahertz antenna installed. There are no small 868-900 antennas available on the market, and as a result of that, you can still have receivers like this size. It's just you're going to need to limit them to the 2.4 gigs band as a result of the antenna choice. As I've shown, you can though get your dual band ones like this, and there isn't really that much of a size difference, but the great thing here with the new chipset is that it gives you the ultimate choice. Now, when it comes to compatible modes, whilst these new chipsets still support the LoRa mode, unfortunately, they don't support the FLRC modes. As a result of that, there are some compatibility differences between what the new radios and receivers with the LR1121 chipsets can use and the original receivers and transmitters that use the older chipsets. However, whilst these new modules don't support FLRC, they do support FSK. Now, this chart here by Sunjun is a great way of seeing all of this in a lot more detail. This is a chart that you may have seen floating around. There's a few versions of it out there. Radio Master have their own one. This is the latest version that was shared with me, and it really does show you in detail what the situation is with regards to compatibility and modes. Now, when you look at this chart, things are color-coded. You can see we've got 3 columns. Column 1 is our 2.4 gigs column, which was our original SX128 series chipset. This is what you would have had on all of the 2.4 gigs ExpressLRS system up until now. In the center, we have modules based on our new LR1121 chipset. And then on the right-hand side, we have our low-band chipset, the SX127 series, and that would have been what was used in the past on low band. Now, this chart is fully color-coded, so you can see they've set the modulation type, so FLRC in red, LoRa in green, and FSK in purple. And you've also got color coding for your frequency band as well. So, for instance, 2.4 gigs in blue. We've got low band over here in this orangey color, and then we've got our Gemini X in this new purpley color. Now, there is a lot of information located around this chart as well. You've got some notes down here explaining what the different mode letters mean, and there's also some hints and fun facts behind my head as well, but the most important area is here in the middle. Now, when it comes to compatibility, this chart shows you what is compatible between the old chipset and the new chipset on your modules. So, for instance, you can see here on our older chipset on 2.4 gigs, you can see that there are blue lines that go across, and that is the compatibility from using the old chipset to the new chipset. So, for instance, all of the old LoRa modes on 2.4 gigs are fully compatible with a new module on the LR1121 chipset with the 2.4 gigs band. You can either have a module with the new chipset on an older receiver for them, or a receiver on the new chipset and a module on the older chipset. However, you do have compatibility across them. What you will note is, whilst all of the LoRa modes are compatible, none of the FLRC modes are, and that is because the new chipset only supports FSK and LoRa rather than FLRC and LoRa. Now, there are going to be new modes, as I understand it, introduced in the future to replace these. If you don't know the difference, the FLRC modes were designed to be the fast, low latency modes, offering the lowest possible latency RC control link, whereas the LoRa modes offered the best long range and resilience link. So today on our new module, you've lost those FLRC modes, but there are more modes coming in the future based around FSK to offer a replacement. With regards to compatibility between the new modules and the older low band chipset, again, you can see up here we have our bars going across. So our 200 low band, 100 full, 100 low, and 50 low band are all compatible. There were only LoRa modes on the old module before on low band. What you will note though is that there isn't compatibility at this moment in time for the 25 Hz and D50. My understanding is is that's not so much around that the module isn't capable, it's more around the fact that they have a limited amount of space for modes on the ExpressLRS system version 3, and they're going to introduce more modes and more options in version 4 that will allow them to bring some of these other LoRa modes back into the new system. Now, you can see there, that shows what is cross-compatible, but alongside this, there are also some new modes down the bottom as well, which we didn't have before. So for instance, you've now got your dual Gemini X modes, so X150 and X100 full. That is obviously only available on the new modules, the new chipset, so you would have to have both a receiver and a transmitter that both were using that chipset to be able to use them. You've now also got on LoRa a 250 low band as well as a 200 full resolution low band, and there is also 2 new FSK modes. This is the start of the FSK modes that they've introduced to replace what we had with FLRC. There's FSK DK500 on 2.4 gigs. They call it a Donkey Kong mode. So that is a Deja Vu or a Donkey Kong mode that's going to offer that similar functionality to the D500 that we had on FLRC. There is also now a new K1000 mode that is available for low band as well. This is the fastest, lowest latency mode that we've had available on low band, and that is only available when using both a receiver and a transmitter with the new chipset. Overall, as you can see on the new chipset, you don't have the FLRC modes, but you do have FSK. And whilst we don't have a replacement for all of the FLRC modes that we had in the past, the DK500 is basically the F1000 mode over the air, just with double the packets. The DK500, the future DK250 modes, they are all a direct comparison to the original F1000, D500 and D250 modes that we had in the past. The ExpressLRS dev team have introduced these based on FSK with forward error correction introduced. They have a GitHub pull request that has a lot of information in it comparing the original modes to the new modes, and they are directly comparable. Now, it's worth me saying FSK has had a bit of a bad rep over the years, and actually it's worth understanding that FLRC is actually a form of FSK, but just with some additional forward error correction added on board. FSK will actually make a nice baseline to allow the ExpressLRS dev team to build new modes on top of it in the future, and it is without doubt that we're going to see some improvements with regards to what we've lost, so those faster modes return in 2.4 gigs, and I'm excited to see what they're going to be able to bring. But again, it's worth me mentioning that you will not be able to have those new FSK modes on the older hardware. You are going to have the newer Lr1121 chipset hardware to be able to take advantage of them. Now, at this point, I want to take a bit of time to explain exactly what the differences and the benefits are of Gemini and Gemini X compared to the standard ExpressLRS modules and systems. Now, the first thing to understand from a hardware perspective is that the standard ExpressLRS module or radio has a single transmitter in it, whereas a Gemini and a Gemini X module has 2 transmitters. A Gemini module will have 2 transmitters on the same band, i.e. both transmitters on 2.4 gigs or both on 868-900, whereas a Gemini X module is capable of having 2 transmitters on independent bands. These Gemini X modules can have 2 on 2.4 gigs, 2 on 868-900, or 1 on 868-900 and 1 on 2.4 gigs. So this allows you to have the most options. On top of those hardware changes, the software is then able to take advantage of that and introduce some new benefits. For instance, the standard ExpressLRS system is a single transmitter, as I've said, and it sends that data out in a serial manner. So you have each packet of data being sent one at a time at a rate that you have chosen in the system. If you want a longer range link, you can slow the data rate down and increase the packet size. But if you want a really low latency link, you can speed the data up and then have smaller packets, allowing for really low latency. The great thing with ExpressLRS is it has all of these modes available, but they all share one slight downside in that there is only so much redundancy that you can build into a single packet of data, and if that whole packet is missed by your receiver, your drone will not update and you will get a choppy control link. As a result of that, and to try and improve redundancy, the ExpressLRS dev teams introduced the D modes, or the Deja Vu modes. These, for instance, in D500 send the same packet twice. So for instance, normal ExpressLRS would send your first packet, jump frequency, send your second packet, jump frequency. The D mode sends the same packet twice, but still on two separate frequencies. So for instance, packet 1 is sent, jump frequency, packet 1 is sent again, jump frequency. As a result of that, you're sending the same packet twice, increasing the opportunity for your receiver to be able to pick up that packet, but the downside is you're increasing latency because you're having to send every packet twice within the system. D250 works exactly the same, but instead of sending every packet twice, it actually sends every packet 4 times across 3 separate frequencies. This then does massively improve redundancy, but that then does come at the penalty of a little bit of latency. The real benefit of the D modes over the standard operating modes is that if you're operating in a high RF noise environment, you're giving your receiver multiple opportunities to pick up that packet of data. Now, whilst this all works really well, as I've said already, the downside to the D modes is latency, because you are only able to send the packets in a serial manner because these modules only have one transmitter. This is where Gemini comes in, because rather than only having one transmitter, you now have 2. And as a result of that, instead of sending each packet one behind the other, you can now still send 2 packets, but you can do them in parallel. So instead of sending packet 1 jump frequency, send packet 1 jump frequency, you can now send packet 1 twice at the same time on 2 separate frequencies across the 2 modules. Furthermore to that, you can even take things to the next level, because you can still have your D modes, but then do that twice. So for instance, whereas I said the D mode on standard ExpressLRS sends 2 packets on 2 separate frequencies, with a Gemini module, you can send 2 packets on each module on 2 separate frequencies, or what is 4 packets across 4 frequencies, again increasing the redundancy. Or on D250 mode, you can go as far as sending 8 packets on 6 different frequencies, again massively increasing the redundancy. Where Gemini X comes into this is that you're then splitting that functionality across the 2 bands. Standard Gemini is the double transmitter on the same band. Gemini X is the 2 transmitters, one on 868-900, one on 2.4. This means not only are you having that increased redundancy, but you're then splitting it not across just different frequencies, but across completely different RF bands. There is no doubt there is a little bit of confusion of where we're at today with the ExpressLRS system as a result of these changes, but this is a step point in time that will allow ExpressLRS to develop more and better modes in the future. If I was going to buy a new ExpressLRS system today, I would be without doubt trying to choose one based on the new LR1121 chipset, just because of the biggest benefit being you are not limited to the band choice unless the hardware design does. That means you can buy a receiver just like this new XR1 from Radiomaster that will work on either 868-900 or 2.4 gigs. The receiver is exactly the same no matter what one you choose. You can simply add a standard 2.4 gigs antenna and just use it on 2.4 gigs. You can add an 868-900 antenna or a dual band antenna like I've got here, giving you the best of both worlds. The biggest benefit to the new LR1121 chipset is that you are no longer limited to choosing your band at the point of purchase. You can now buy a transmitter and a receiver that both support dual band, and you can then choose whatever best suits your needs at the time of your build or at the point of flying. I don't think we're going to see the end of the older ExpressLRS hardware overnight, but I do think you will see pretty much everyone in the future transition over to these new chipsets. And whilst it might initially look like on the chart that we have lost some of the fast rates, remember the DK500 is a direct comparison to the D500 that we had before. This is the most widely used fast rate because it offers that dual packet transmission, which means you get that additional redundancy and you get the low latency. And whilst we might not have the standalone F1000 that we had before, more modes will be coming in the future. It's less of a loss, it's more of a streamlining of the modes down to what is most used, but I'm sure this will expand over time. Now, if you're interested in finding out more about any of the hardware that you've seen here today, I do have info and reviews on all of them. You do now have the new receivers from Radiomaster as well that support the LR1121 chipset, and there's a whole new range of them giving you options to have the XR1, which gives you dual band, the XR2 for the people who want the smallest package, but that one is limited to 2.4 as a result of the antenna, or the XR3 that's going to give you diversity, or the XR4 with the dual chipsets, which is going to give you Gemini X. Obviously, Radiomaster have been one of the big manufacturers to jump into this, but I should also say you are going to see more hardware from other manufacturers in the future, I'm sure. For instance, GEP-RC already have their own Gemini X receiver available on the market, and there's also models available from BAYCKRC as well. These are available on AliExpress, so we are starting to see more and more different models hit the market. But when you are making your purchase decisions, just make sure you understand what chipset you're buying and what compatibility that is going to bring. Now, I hope this video has helped you understand what the situation is. If you're interested in seeing the review of any of this hardware, as I've said, there will be links to it in the description and there'll be a playlist on the channel. I'd also just like to say, if you have found this video interesting, please consider supporting the ExpressLRS project. They do have an open collective page where you can make a donation to the ExpressLRS project to thank them for the amazing work that they have done. That project has done more for FPV than pretty much anything else outside of Betaflight in the last 5 years. So if you're interested in seeing that, please do consider checking it out. Also, if you'd like to support me for what I've done here, please consider checking out the links to my Patreon as well as Buy Me a Coffee. It is only through the support of my Patrons am I able to keep making content on this channel. And if you'd like to support us to allow us to keep making content in the future, please do consider checking it out. I want to say a massive thank you to all of my Patrons. We would not be able to do this without your support. Anyway, that's it from me on this one. I hope this explains some things. Stay safe. I will speak to you soon.